Hello there. Today we're going to take a look at the mess you can see right now, which is a project that turned out very differently from what I initially thought. I wanted to restore one of these luggable 286 PCs with an integrated screen which looked like a suitcase. And if you know me, I already have one of these suitcases turned into an Amiga. And today my goal is to turn, well, initially my goal was to repair the 286, make it nice and shiny and new again, but well, that didn't happen, as you will see in the progression of this video. So mid-video I decided to take a turn and use this luggable computer to create an SX64 version 2, so to say, with a better screen and a bigger screen and some extra features you wouldn't find in an SX64. And this is inspired by a video by Retro Combs, who bought this Raspberry Pi 400 case with a screen which turned this into a kind of notebook. And I just thought for 250 bucks, I think he paid for that. That wasn't too good of a deal, plus the Raspberry Pi and a power supply and all the stuff. So I wanted to be way below that budget, and I paid 50 for that luggable computer. The screen is dead, but that is not much of a problem because magic, we can replace that. And yeah, then mid of that project I had all the parts and speaker and what you need to build such a machine. I thought, hey, what about if I try to do this without soldering? Would it be possible to turn one of these luggable computers into an SX64, which looks good and works very, very well, maybe even better than the original, without doing any soldering? And yeah, that is pretty much what this video turned out to be. And I'm mid-project, so I have almost all the parts. I'm waiting for some. But I think it's doable. So in the end, we will check if it's really doable to do a video like this or a project like this without soldering and just connecting components. And I will put a list of all these components at the end of the video. So yeah, let's dig in. And the first, I would say, third of the video will be the unboxing of the suitcase computer and trying to get the 286 running. Then I will switch to the project of putting an SX64 into this casing and all the steps that are required. So grab a cup of coffee or whatever beverage you choose, and let's strap in and get ready for the ride. Today we're going to take a look at this machine. Doesn't look like much of a machine, looks like a huge brick, but it is actually a computer. And yeah, let's check it out. It came with this mystery package of stuff and wire. So in the front it says BOL Videograph Computer, and there's some writing down here. This is supposed to be a PC. I paid 50 euros on eBay for this. So it has a little clicky keyboard, which is nice. Let's put this to the side. So this is the cover for the PC, and it's a keyboard, and it seems to be in pretty good condition. And it's a PC keyboard. It has a screen, and the speciality of this screen, and pretty much why I like this, is it has the right form factor. And I'm planning to put, if this doesn't work and I can't fix it, I'm planning to put in an iPad 2 screen this time. And you can put this out and you can put it the way you like. So this is a little wonky, so like this, and you have a perfect screen, and you plug the keyboard in and you have a good workplace. You have a brightness control here, which is pretty much all there is. And if you push down, you can put it somehow back in here. Yeah. It has a carrying handle, which is really dirty. We have on the side, let's see, we have what seems to be a VGA card. We have a serial port, 9-pin, and a printer port, a parallel port, and the VGA card has some mouse piano on it. So some dip switches, and we have a keyboard connector down here. On the other side, we have just 2 holes where I assume was a 3.5-inch drive and a 5.25-inch drive, but it is no more. On the back side, we have a Type 28 sticker. It's made in Taiwan and it's 302069. We have a spot for what I assume should be another serial port. We have a switch down here, which I think is to switch between 110 and 240 volts for the power supply, and we have an on-off switch and the power socket. On the bottom there's nothing to see, so let's plug it in and see if it has actually some life in it. I don't know. It was sold as used but not broken. Let's see what gives. Let's plug in the keyboard. Like that. Oops. Okay, let's fire it up. And it does give some sound. Not sure if the screen is on. Oh, it beeps. Not sure if the screen is on. Nope, doesn't look like it. But there seems to be something going on. We don't have a hard disk, I assume. Since all the drives are removed, I assume the hard disk is removed too. Yeah, so let's open it up and see what's inside. Maybe let's first take a look at the mystery package. It's rattly, so let's see. Okay. So these seem to be some mounting brackets or stuff. I assume for the drives. Okay. Let's put this to the side for now because I have no use for it right now. And to open this up, we first have to unplug it. Don't want to get shocked. Here seems to have only 3 screws, here, here, and here. And this should theoretically, yeah, lift off. And here we are. We have the drive cage here, which I will try to take out. Okay, here we go. So this is a drive cage. So now we have at least a better look at what's inside. And this seems to be a 286. Let me strap in before I kill that machine, because it seems to be working somehow. So here's a speaker. I assume this is a memory BIOS, which is an AMI BIOS from 1986. So we have some cards here. This is the drive controller cards for the disk drive and the floppy drive, the hard drive. We have some stuff here. So let me first get the cards out of here. Okay, I guess we have to first take out the VGA card, and that has a connector for the screen on the front. So this here somehow connects to the screen in front. So let me take that off. Okay, and here's a power connector for that. So let's take the tallest card out first, which is the I/O card. Yeah. Okay, and this is a non-descriptive, I don't know, whatever card. BOL GmbH. Okay, so these seem actually to be the manufacturer of this machine, not just some slapped on brand. Let's take the VGA card out, which is this beauty. OTI VGA, Oak Technologies. Not sure if this works, but the interesting part is, of course, this connector here, which then should power the front screen, or at least transfer the data to the front screen, which is pretty nice. I've never seen that before. And now we can hopefully get this controller card out. Therewith comes a whole slew of cables, and this is connected somewhere here. I assume this is a drive LED. Let's pull this cable and take the controller out. Okay, all that's left now is the screen cable, which is powered through this adapter here, and the main board, which resides below the power supply. And this is hanging pretty loose here. And this doesn't seem to be some specific main board for this machine, because it just there are just 16-bit ISA slots below the power supply. So let me try to take this out somehow. Okay, now we have that. Oh, and there is a really crusty Vata down there, which is very uncool. Ooh, that's a beauty. Doesn't seem to have done too much damage, but still, it's an ugly beast. Everything seems to be in order, and I think first order of business is to cut this out, but you have some real nasty stuff over there. I think we have to take this out of the case and take a closer look. Ooh, that crustiness. Beautiful. Okay, much better. Okay, first order of business is to remove this Vata battery here, which is pretty stuck on there. So I think we are in luck. The corrosion is pretty much just in this area right here, and that should not affect the machine. I will use some vinegar to neutralize the corrosion, but for now, for our testing purposes, this should be sufficient. So can take a closer look, which is an AMD N80L28612/S from 1982 and an AMI BIOS 268 BIOS Plus from AMI 1986. Chips on here, this is from 91, is this 12 of 91? I think it is. Yeah, so let's reconnect the power supply and let's try to get an image somewhere. I will use, I'm not sure if I will use this VGA card. Maybe I use another VGA card. I'll have to check if I have one. I will at least clean the contacts because they are pretty rough. It's not that bad. I've seen worse. Like this. The red wires go to the outside, so I think it was like this. Yeah, that should work. Let's give it some power. Let's first see nothing explodes. Power supply is running. Machine, no idea. Ah, I disconnected the speaker, so no sound there. Okay, but it's still alive, which is good. And the VGA cable. So nothing is plugged in except for the VGA card, which we don't know if it works. Let's see what it does. Do we get an image? Are we even... Ah, hey, look at that. Oh, technologies, 1 meg of RAM. Nice. So this thing actually works. Yeah, okay, no battery, no system options, HDD controller failure, keyboard error, run setup utility, F1 to resume. Okay, I can work with that. Let me plug in the keyboard. Let me grab a disk drive to test. And yeah, let's take it from there. Okay, I have this pretty precarious construction. Keyboard is connected here. I have plugged in the controller card again for the disk drive because 286 and I think 386 too, the most of them don't have their own onboard floppy or hard disk controllers. I've attached a disk drive, of which I'm pretty sure is a DOS drive or a PC drive. So let's fire it up again. No explosion so far, which is good. And we still get the screen, American Megatrends. Oh, battery state low, system options not set, display type mismatch. Okay, so let's press F1 to resume. And we get not much. So, Control Alt Delete. Unsupported mode. Oh, flashy, flashy. Let's hit Del to enter setup and diagnostics. Run setup utility. Yeah, I would, but there's another key down here. Let's try this one. Doesn't let me go into the setup. So how can I get into the BIOS? Okay, the board works. These cards, at least the VGA card works. I know that. Don't know if the controller card works. Don't know if the serial parallel card works, but I don't care right now. Let me think. So I did try to get into the BIOS of this board, but no luck. It works, but I just can't figure out how to get into the BIOS. The keyboard seems to work fine too, so yeah, no idea. So what I'm going to do is I will leave the board out for now, and I will take the machine or the casing and the screen and I will clean it, and I will turn it into a C64 SX or an SX64. As I said in the introduction of this video, at some point in this whole project of restoring the 286, I went for broke and I just disassembled the whole case. And this is what's left, plus some parts which are behind me. Yeah, those wheels weren't on the case actually. Yeah, so now the plan is to turn all this mess plus some more components into an actual SX64, and doing this without any kind of soldering. I will maybe show you what you could alternatively do if you would solder, but yeah, let's try to get this running without any soldering. let's take a look at how to install the BMC64 and why I choose BMC64. BMC is a project by Randy Rossi, who most recently did the new VIC-2 chip, the Kavari, the Kavari VIC-2. And BMC64, I think, is from 2020 or 2019. And the idea is, and that is what the BM stands for, the bare metal. So there's no Linux layer for the Raspberry Pi. It just boots into the C64, and this takes just 3 or 4 seconds. And it features an almost no lag and a really good implementation. And it's based on the VIC C64. So it says here you have quick boot time, C64 in 4.1 seconds. Frames are synced, low latency, no shutdown sequence, can just power it off. High compatibility thanks to VIC, because it's based on VIC. Easy wiring for joysticks on the GPIO pins, we will take a look at that later. And even the original Commodore keyboard. And it also works with the Kira if you want to use one and don't want to do the wiring yourself. But, well, the Kira is hard to get at times, and the wiring is quite easy. And it's sort of free, so I will show you how to do that. And what it doesn't say is that with the BMC64 there also comes the 128, the VIC-20, and the +4. So you have 4 machines which are bare metal, and this is really great because he put it all into one distribution and you have just one file to install. So the most important thing to do is to go to the BMC64 website, which is exchange.com/BMC64. So you need a blank SD card, and then you go to downloads, and you don't download the zip file here, you download the image file, because the image file is already done, and what you get is pretty much a blank installation, and you only have to add the kernel and the ROM stuff. And I will show you how to do that in a minute, because it's a bit involved, but not much. So let's download the image zip. There we have it. And you just unpack this wherever you like. I already have it unpacked on my desktop because I already did all this. And then you open Berliner Etcher. I will put a link in the description. And you say flash from file. Your SD card should be inserted into the machine. Desktop. Find the BMC64 image. Select target, which is the SD card. And I think it has to be at least 8 gigs. Not sure. Could be. I have a 64 gig card, but I'm deleting it anyway, so you say select and you say flash. And that takes a moment. And that's the SD card flashed. You can just close this down and open this up. And as you can see, there is no SD card, so you have to eject it and put it back in the machine. I will just do that. And there it is again. And you can see it's a complete installation, and you have different folders for the machines. And it says put ROMs here. So you have the C64 128. You have the PET, the +4, the +4 EMU, which is a better implementation for the Raspberry Pi 3, and it's a little bit faster. And you have the VIC-20. So these are the machines, and you have to provide ROMs for all of them in their respective folders. You also have a directory called cards, disks, and tapes, and PRGs. And here you can put your cards, and this is again organized by machine. And these are the default directories. So if you say mount a card, you will, on the C64, you will land here. So it will put you into these default folders. So put your software here, and here, and here, and here. We theoretically could put this card into a Raspberry Pi 3, and we would get just a black screen which says no ROMs. And to change that, we have to put ROMs here. So let's see. And it says here we have to go and put a kernel the character generator, the basic, and the D1541-2, ideally, ROM here. So these are the 4 ROMs. And we can find these on zimmers.net. I will put a link in the description. Problem is, they are not named like they are named here. So we have, for example, the character ROM, and you have different character ROMs here. And what we want to have is, we want the standard character ROM. Let me quickly check. The Swedish, Spanish, Danish, and we want that one here. So let's just save that somewhere. And it's called a bin file. So let me quickly put that. Yeah, I already have these downloaded here. So what you want to download is basic.901226-01, the characters 90122501, the kernel SX251104. And as you can see, I just selected pretty much the same here. If I say save, that's already there. So we need this one. We want to have the SX kernel, which is Scandinavian. We want this one right here. We want, where's the basic? We want this basic. And we want, yeah, the floppy ROMs, but these are not here. These are, if you go back and you go to drives, new, 1541, and there you should find a 1541-2 ROM, which is this one right here, and you download that. And since I already did all that, let's go to the download folder. That is here. And here are our ROMs, and we have to rename these. And you have to be very careful to rename these correctly, because the emulator just searches for these names, and if you don't provide these names, you're out of luck. There's no way to get this running without naming these correctly. So let's see what these should be named like. Kernel character gen or char gen basic D1541 II. That's 2 I's. We have to remove the bin because we don't need the bin. D1541 II. We have to call this just basic, and again remove the bin. We have to rename this to char gen, and this to kernel, and that's with an A. And then we go and we copy these 4 files over to our SD card in the C64 folder where it says put ROMs here. Just say insert, and you have your C64 up and running. That is just the C64, and I will only do the C64 in this video. If you don't want to do all this stuff, I have C64, C128, PET +4 AMU, and VIC-20 ready in a zip file which you can download from my website. So you just unpack it here, and it will overwrite your C64 128 folders with all the kernels ready to rock. Since we are here, let's quickly check out the config file, because if you do this yourself and you try to, for example, start the PET and have all the ROM files in there, but there's one missing or named wrong, you will get a black screen, and the machine will stay on that black screen. It will not automatically go back to the C64. It says in the manual that you can do this with keys, but didn't work for me. So the easiest way is you go into the config. If you scroll down completely, you will find the last booted machine here. So if you boot a machine other than the C64, which is the default, it will be here. It will say here PET or +4 or VIC-20 or 128. And if you delete this line, which is here, some machine that's booting, just delete that line and save the config file, and you're good to go. and your machine will boot into the C64 again. You can also do some changes here, and so that's the config. And if we want to change, for example, the audio output, we have to go into the machines file and machines.txt. And here you can configure all the machines. So there's settings for all the machines and the screens and stuff like that. So the VIC-20 has different modes here. C64, all the machines have their own modes. And what I will do now is I will set the audio to analog. And it says in the documentation that you should do that for every machine. So I would have to put audio out on every single one, but I'm just using the C64 PAL HDMI VIC. So if I put audio out analog here, that should do the trick. I'm not sure if I use this or this up here, so I will put the audio out here too. And if this works, you just add it to all the other machine settings here. Okay, so that should pretty much be it here. Yeah, I think we are good to run this on the Pi now. By the way, all the other settings are done on the Pi itself or in the emulator. So configuring the joysticks, switching joysticks, all that stuff is all done in the emulator, and I will show you that when we boot the machine for the first time. My idea is to put in a Raspberry Pi 3 into this casing, replace the screen with an iPad, which I have lying around, an iPad 1, no, it's an iPad 2, which gives a very nice screen. Yeah, and I will even use this keyboard here, which came with the machine. Yeah, so I started scrubbing this grubby thing here, and it's really, really, really dirty. I'm using cotton pads and alcohol. And it's taking all that stuff off very nicely. But it is really, really, really dirty. Much better. Almost not afraid to get a disease by touching it. That's nice. I will take a magic eraser to these scrub marks. These scrub marks here. I have to remove the screen. I have no idea how to do that. So here's the cable, which also is a power cable. It seems here are middle screws, but they are missing. So it's just the 3 on top and the 3 on the bottom, and I can get to these by just turning this around. So I can take the front off without removing this whole construction here, which is good because I don't want to. And then I can just put my iPad screen in here and check if it works. Okay, I managed to get the screws out, so let's see. Ah, okay, that is still screwed in there. Turn this a little, you can see this. There's this plate which holds down the whole thing here. Okay, so here is our screen. I mean, look at what all goes into one of these screens here. Let me try to... Okay, so now we know that this part of the cable here is for these LEDs in the front, which is good, because we will keep this, and we'll have to undo this cable here and this, like this. Just 3 LEDs on a stick. Let's take a closer look at this. This is just great. I love it. So we can maybe use this as the volume dial for the C64. Not sure yet. This is an OKI panel, plasma display. Okay, this is a brightness control, which is just here. I'm pretty sure we can just use this. It would be awesome. Okay, let's unplug this for now. It should give us the panel, and it does. Ooh, there's an actual glass screen. Interesting. Not sure if we can reuse this bracket here, because all this stuff here is wrapped around it. So this is glued together and wrapped around, and I've never seen anything like it. Yeah, the board looks good. Can't see any obvious problems with it. Yeah, I think this whole construction is just one whole construction. Nothing to see here. I will just leave it like this. Maybe I can reuse this at some point for something, but for now this just goes to the side. So let's grab the iPad, which is here. Oh, it already started, which is kind of nice. Yeah, that should work in there perfectly well. So I already ordered one of these driver boards for this. I have videos about how to open these and get the screen out, and I will do just that. I will not put the iPad in like this, because it doesn't make any sense. I will actually open it up and use just the screen, which, if you check here, seems to be a little smaller than this here, which is unfortunate. And let's try to get this out of here. So it's glued in here, so we have to actually give it a little laugh and move it along. And in this iFixit kit, there's some stuff which we can use for that. I think, like this monster. According to iFixit, there's actually pretty hefty glue in place here, and you have to heat this to actually get it open. So, I could use the hot air gun to do this. They have some kind of heating pad that you put into the microwave, then place on here. I don't want to destroy the display, but however, you have to get between these spots here, which is not an easy task. I think I got it. Oh, look at that. I really think I did it. Without heating, actually. We put something in there just to keep it open. Like that, by moving this along. I hope it's just the glue. Yeah, that is some hefty stuff here. Oh, it feels like breaking stuff all the way down. Yeah, this tool is definitely working. Oops, there's some glass cracking, that's not good. Just hope that's not the screen. Yeah, something cracked there, not sure. I hope it's just the inner glass. And you can actually just push it a little. Oh, that's where the glass cracked, right here. So there goes our screen protection. I hope the screen is still intact. Okay, I think we're in. Screen looks good. Yay. Nice. Okay, I think we have to recycle this because this is broken hard. So the screen looks good, which is the most important thing, and there are just a few screws, I think 4 screws here, which hold this in place. So let's remove these. And here is what I came for, which is the screen, and that is just held in with these little clips here. There's a little thingy which you can just flip over that locks this into place and take it out. And there's an iPad screen, which works just fine. By the way, this is a number you have to check for if you are looking for the controller board for this, which just plugs in here. So you can lose this cable here, just plugs in here on this connector, which you can just remove the sticker just on here. And there's another one of these connectors. You just pull up and take it out like that. And here's our screen. So here are the different batteries of the iPad, camera module, all the stuff, and I will just put that on eBay. So maybe someone can use this to fix his iPad. Let's see how that screen fits in here. And right now I don't know the orientation of the screen. I think this is up, but I'm not sure. Could be down. So this would go in here like this. We would be having a screen, but you can see it's a bit too small. So I did shoot this video for a few weeks actually, and finally the hopefully correct controller board for the iPad display arrived. What I did is I did cut some fresh plastic protection here, which is just some stuff I had lying around. And I placed the iPad on top of this, and I just put some electrical tape around, so now I have a perfect bezel, so there's no 3D printing involved. So let's see if this controller board actually fits and if we get an image. So this came all the way from China. Oh, it even has a remote. That's nice. You can see that these wires are super thin. So this is the control board for menu and stuff like that. Here's a remote sensor, the IR sensor. So yeah, we need some power. I think it needs 12 volts. Yeah, it needs 12 volts, it says here. And we have composite, VGA and HDMI. Let's see. I have an HDMI cable somewhere here. Here it is. Plug this in here. And we need to connect this little cable here to this right here. It's in there. Let me put some electrical tape there. So it only goes in one way around. That's good. Okay, so let's plug in some power. Let's plug in some Pi and let's see if we get an image. And if we have the right orientation, because else it would be very stupid. And for now I will be using this variable power supply. I used this in a different video, I think. You can just plug it in and it gives you a voltage, which is 11 right now. You just turn this dial a little Oh, that's too much. And it's also very fiddly. Yeah, that should do. And then we plug that in here. And hopefully don't blow it. Okay, we have an image. Do we have an input source? Okay, so it's here HDMI. Very nice. Okay, so let's fire up the Pi. And there we are. The Pi is not happy. So there is something you can set up. Yeah, it looks like a good picture, actually. Okay, so that works. That is awesome. First try. Wow, I'm pretty impressed. And it looks really, really good, as you can see. And we can do some settings in the BMC64 to, I think, even widen the image. But that looks great already. That is very cool. That is very, very, very cool. So with a screen, that's a huge step. Now I have to put all these boards in here somehow, or in the casing. Here we have to find a solution for the HDMI cable, which needs to go through the case. So let me check that out. So I did tape some plastic back to the back of the screen here. I untangled these cables here, and I will put that controller board right here so that I can go like this. I think I'll do it like this, so I can put this power unit somewhere here, just sticky tape it in, and I can put this through the hole here, and I can actually use the controller board on the other side of the screen, so inside the case, or I can just maybe even route it outside the case. I'm not sure yet if I really need this. So I will just double-sided tape these power strips down here like that. That goes right here. That should stick there forever. Now we take this and tape it in somewhere there so that it doesn't rattle around. Let's put this right here. Like this. Nice. So we can cable manage this little inside this thingy here. And I think just a bit more electrical tape to keep this in place. Give it some strain relief. We should be good to go. Yeah, nice. So this can be routed outside the case, or outside the screen, along with this cable here, which I need a longer cable, I just noticed. No problem, I have. And I have to extend this slider here because I want to use this for volume control. So I have to put in some of these DuPont cables, the one with a pointy end. Okay, and we just put these in here. Let's white be white and black be orange. And again, we use some electrical tape because we don't solder to keep this stuck together. Nice. We can just route that out, and I think we could even do another one of these. Like this. Nice. Good, we have that. It should be at least long enough to get into the case. I guess we will put some electrical tape on here, on these contacts, just to give it some strain relief. Like that. Okay. We have to take care that we get some power cable in here. How do we do that? Alright, we have to connect that voltage transformer. So we have 3 cables going in this case here. Okay, let's take a look at the keyboard, which is a nice clicky one. And let me grab my keycap puller so that we can take a look at the keys. These are this type of keys, which is not the standard for modern keycaps. So I had an idea to replace the keycaps here with modern keycaps because I found something which is interesting, but I think it can't be used here, and this is these keycaps, and they might look like normal keycaps, but let me show you. By the way, I got these on Amazon Prime Day for I think 20 euros. If you take a look at these keys, you can see they have the PET characters on them. They even have control, run, stop. So this is a standard key set. This is 2 layers. Let me get the second layer open. 2 layers of keycaps, but unfortunately they are like this with a cross, which are modern keys, and these are not crosses and they don't fit, which is a shame. So I can't use these keycaps, and they are very flat. So I have a modern keyboard, mechanical keyboard, where I can use these, but yeah, not on this keyboard. So we need a better solution, and that is not the only problem. The other problem is we have this connector here, but we don't have this connector here. So I put a USB hub, one of these super slim 4-port hubs, on my Raspberry Pi 3A, but still hard to connect. So we need a solution for that, and luckily there is. First, there's this DIN 5 to PS2 adapter, which is great because we can use this inside of this plug, which is part of the case. So we can plug this in the case, and then we can actually use this as our new keyboard connector on the case. You can plug this in here. And on the other hand, we need a PS2 to USB adapter, and luckily these are available too. This is one of these here, and here's the keyboard connector. You plug this in, and then you can plug this into this, which is yeah, always 3 times around. Awesome. So we have a connection. Oh, I have this thing still on here. We have a connection for our keyboard, which is great. So that problem solved, and we didn't even have to solder anything. We don't have controllers yet, but we will get to this in a minute. The other thing is I want to see my PET characters here, and for that I got this, which is a stickers sheet. I think I got it from Vesalia or any other retro computer shop. I will look it up and put a link in the description, and you can use these stickers with all the keys to make this actually work. And to do this, I have to start the C64 on this, and I have a new monitor here, which I got also from Amazon. Let me show you. And this is one of these super fancy, super flat monitors which look like huge iPads. It has sound, and it has HDMI in and USB-C in. I can use this with a Pi for now to do testing and find out which keys are which. Let's try to figure out which sticker goes where and put it on the keyboard. So I think before I will put on stickers, I will first clean these a little, because this one here seems to be the stabilizer missing, so I will have to take this off and take a look. Keyboard is relatively clean for the age. There are some scuffs, but there's almost no dirt between the keys, which is always interesting to me, because it seems nobody really used this. Let's take off some more keys. If you take a look, there's nothing in between. The case is a little dirty. I can clean this quickly, but nothing between the keys, which is awesome because it saves a lot of time. I will quickly clean them. Also, they are pretty clean. We'll just use some IPA on a cotton pad here. Just give it one quick wipe, which should be enough. Yeah, and there's almost nothing on there. And then we will put some of the stickers on to test this. Okay, there is actually some dirt here, so it's good we cleaned that, but it's minimal. It's really minimal compared to other keyboards like the Amiga keyboards from my previous videos. This is nothing. I might not even have to take them off. There's some dirt between the keys here. I will use, I think, just some Q-tips to get in there. They are just a slightly bit yellowed. Nothing dramatic, so not too concerned about that. So let's put these back on. And let's get stickering. These actually turn out. That looks good. Fit perfectly. Yeah, you could argue that they are a lot lighter than the other keys. But still, I got a C64 keyboard, and these stickers are not so uncommon. Commodore actually did that on the Amiga 1000 keyboards. Let me show you. At least on the German ones, there are the stickers. So it's not even inappropriate to do so. So I will sticker the keyboard and I will get to you when I'm done. So I did finish the keyboard stickering. And I think it looks pretty nice. Not sure if I should really leave the stickers on these here. So except for the Commodore key, of course, which would be that and the control up here. But I could remove these, this one, this, and all of these. But I'm not sure. It looks pretty even now. Okay, so I think that is the keyboard fixed. I will have to clean the case still, but it took me 45 minutes to sticker all the keys. Had to cut the shift key stickers and the return key sticker to fit. Yeah, so on to the next topic. So this is a project I did a few years ago, which is a Raspberry Pi game console with speakers and a screen, small screen, inside an IKEA frame. And I will reuse some of the parts I used here, like the speakers, and this was also one of these projects with no soldering, I think, if I remember correctly, because this is just some cardboard here, and this button doesn't do anything, and this connector here, I think, is not even connected. Let's take a look. So, as I said, it's just a frame, and here is what is inside the frame, and these are the speakers, which were some, I don't know, cheapo speakers. Here's the power bank I need. If you turn this around, I think you can just pull this off. Yeah, and I screwed these into the cardboard. And I liked this because it made for a very, very clean look. So this looks good. But I'm not using it anymore, so let's reuse it for something else. Yeah, this project has a lot of screws involved. They are just put in here like this. Okay, I see. I think the video for this is up somewhere. I'm not sure if I made a video. I think I did. But by watching me disassemble it, you might get an idea of how to assemble it. So, not sure if this power bank still holds any power. Oh, it does. There's a little charge in there. Look at that. Oh, nice. Ah, satisfying. Good. We have a power bank, which is 20,000 milliamp power bank, 3.5 amps, which should be plenty for what we have to do with it. I'm not sure how I did get these in here. I think I soldered them, so no soldering. That will be interesting how I can get these out of here. This. Halfway through already. And the other half. See, no soldering. Okay, now we have speakers, which is good. I also had these speakers here, but you can't buy these anymore, so I can't link them. And I don't want to cut them open because they cost, I think, 11 euros, and they are really good speakers. So I don't need that right now. So I will just use these cheapo speakers here, which are also okay. They're not great, they're just okay. And they also use HDMI for power and that plug, which is good. And what we will do is we will just plug this into our USB connector here, and this into the Pi. And that is pretty much our audio done. And we have a volume control here. Yeah, that is one thing. I can't use the volume control on the screen if I don't solder. So that is a compromise. I will route this outside the case so that I can actually control the volume, and it will just sticky tape this somewhere outside the case on the back. But if you would solder, you could open this up and you could solder the contrast slider to be the volume control. Maybe I will do a follow-up video where I really use a soldering iron and do the whole project, redo the project, and see if we can optimize it by soldering stuff. Okay, so that is that. Let's see if we can actually use this power bank to power some speakers, and we will use these white speakers for that, just to check. Nope. Let me see. Ah, now it works. So that's our charge. And yeah, that does actually work. I have another power bank on the way which uses USB-C instead of micro USB, because I have a whole power cable situation thing prepared. But for now I will just use this one right here. So let's talk about the joysticks. You can buy these joystick ports, these 9-pin Atari joystick ports, with these connectors on here. I soldered these myself, but you can buy these ready-made. I will link these in the description to the video. And what we can do is we can just use some DuPont cables to connect to this, and then we connect these to the Pi, because in the BMC64 there's actually a function to use the GPIO pins as the joystick connection. So you don't need anything like Kira or stuff like that. You can even use a real C64 keyboard, which I don't, but you could, and you can see in the documentation of the BMC64 how to use this. What I will do now is I will connect two joysticks to the Pi 3, and then we have the controller situation solved. We have to do some software settings. I will show you where to do that. And yeah, that is pretty much it. So it's just putting on some cables, and we need 6 cable per connector, so 3 pins are not used. And I will show you how to do this. So I have my joysticks connected already here, or my joystick ports, and you can switch in the software between this block here, which is block 1, and this block down here, which is block 2, and you can decide which joystick is which. You can also only do one joystick, and you can switch in the software, and if you only use this on your own, then you don't have to actually connect 2 joysticks. So this is already connected. You can see it's the same, and these go exactly the same. I have these colors here. I have purple, blue, green, and yellow for the top rows, and these just connect to the pins 1 to 4, like this, just like here. And on the other side, I have brown and black, and brown goes to pin 6, and black goes to pin 8, which is ground, and that is pretty much all there is. And then you have to connect these to the Pi, and not sure if you can see that very well. These connections are different on these 2 blocks. So you have, I will put up a little graphic here so that you can see which color goes where. Yeah, use the same color as I do, or do it accordingly, and then you will be good to go. And this is the controllers solved, and you can use any normal joystick on that. I have my, what's it called, the Retro Radionics Arcader here, which in my opinion is the best ever joystick for the C64 and Amiga and all the 8-bit machines. So you just connect that here and off you go. Let's talk about the power situation. We have a system which needs 5 volts for the speakers, 5 volts for the Pi, but 12 volts for the display. And my initial idea was to use the power supply that came with the machine, and it's right here. And I tried everything to get it started, but it just won't. I built one of these fancy cables. Yeah, I know, no soldering, but for testing. And that would just plug in here and would then give 12 volts 2 times, because I initially thought I would have a stereo module which would require 12 volts. So that was a very, very early attempt. And a 5 volt USB cable for the Pi. So I could easily swap that out for a second 5 volt line and a second USB plug or USB female to plug the speaker in. But it won't start. And it's one of these older power supplies which don't have the ability to, just kickstart by connecting the purple cable to ground. So yeah, it seems to be that it needs load on the 3.3, 5 volt and 12 volt line, and this must be balanced so that it actually starts. That was what I thought. Then I thought, hey, let's take the bracket off and put another power supply in. And then I saw this. And it says, this power supply for high contrast plasma only. Burn in. And by the way, fancy design, because this goes to the side of the case. This side, it's not even closed. And this is some generic power supply, so I have no idea which one it is. So that won't work. So I decided to put this in to the case, but just for the weight, so that it feels a bit more hefty. Yeah, that was one plan, which vanished soon. So my next plan was to use a power bank like this, which has one in and two outs, and to use one in to connect to the power line, so to get power from a power brick to load this, to have one of these 5 volts go to the Pi, which would then over the USB hub power the speakers, because that works. And the second line should go to one of these voltage transformers, and these take 5 volt in and give 12 volt out on this side. Same here, so 5 volt in, 12 volt out. Problem is, these don't punch enough to get the LCD panel running. So that was the next hurdle. So no luck using 5 volts, because yeah, not good enough. With that died my idea of having a real portable SX64 with a power bank as the battery, because that would have been pretty easy. You plug in power, or you start power, you plug in power, or you just switch on the power from the outside, and this starts running, and then it starts the LCD and the Pi, and it would all have been yippee-yay. But yeah, no, that doesn't work. So we can't use 5 volts and step this up to 12, at least for now. I should get a delivery today which has another one of these 12 volt step up thingies, and maybe that gets the LCD panel running, but I don't have high hopes. So I came up with plan number 3, and that is using a 12 volt power supply, which has in this case 5 amps, 12 volts, 5 amps. I have one around with the wires already cut, so yeah, you can cut these yourself. Not on this side, which is the power plug side, but on the 12 volt side. And on that I will put one of these things which you can buy, which is a step down converter. So it takes 12 volts and it puts out 5 volts, 3 amps max, which is pretty much what the Pi needs. So my plan now is to connect this and this. So this goes into the display. I then have 2 USB plugs I can attach to the speakers and the Pi, and all should be good. Yeah, problem is there's no power switch. So the moment you put this in the socket, it runs. If I could use a soldering iron, I could use the switch from the original power supply and make it all a bit more elegant. Lose this cable and use the original plug, and you wouldn't even notice that the original power supply is not running. But we said no soldering, so I will pretty sure do a follow-up episode of this video where I use a soldering iron and I go over these, let's call them hitches, and yeah, make them pretty. Until then, I have this, which is already soldered, so no soldering iron used. Okay, that is pretty much cheating, but I had that from a different project, and what you do is you plug this in here and you can screw that into the case, and then you have a power outlet on the case, and you can actually use this to put in the cable. In case of no soldering, we just route the cable through the case opening somewhere, preferably near the expansion card brackets. There are 2 slots for the speakers. We can route the cables through there, and that should work. And we will just twist these cables together and use our good friend the electrical tape to make it happen. Yeah, so that is pretty much the plan for now for the power supply. So let's get building. If this works, good, I have a plan 3. If it doesn't work, I'm still hoping for the step-up converter for 5 volts, because that would make this whole system portable, which would be awesome. Good, let's get cracking, and I will twist these cables together and I'll show you how. And yeah, then we can go our way. And we have these adapter cables, of course, which plug in here, or one cable for the Pi, and the other one is just the USB cable from the speaker. and we have this which goes into the display, or this, it's just the same. So you can buy these cables on Amazon, and as always I will put links in the description, and they actually fit. Good, let's build our cable. For that you can use scissors, or back in the days I used my teeth to get this cable stripped. Don't do that anymore. This cable too. Make it a long one because it's easier to do that with short cables. And also you can these make for better contact here. So it's not very complicated. Make sure that black is actually the ground wire on your power supply, which it should be. You can see it here. It's black and red. So red is plus and black is minus. So you just twist all the black wires together. It should be pretty easy. And this is not the recommended way to do it. This is just the way we are doing it now. Like this. Bend this to one side. You can already see this is getting loose here. So we have to use quite some electrical tape to keep it in place. And this is just for testing purposes right now. Press firmly and then just put the tape all around the wire. Make it stick. Okay, and the other one, in my case this is a white cable, but it should be red if you just cut the end of your power supply. And again, use some electrical tape for good measure. And speaking about measure, let's plug it in and see if it actually works. Because we should have 5 volts now and 12 volts. Come on. Okay, that looks good. No explosion. We like. And let's measure this, at least on the 12 volts line. And it should give solid 12 volts. Let's see. 12.3, which is good. I think we have the power situation solved, at least for now. It's not elegant with a cable hanging around and no power switch, but that is the way it is without soldering. You could probably attach some kind of extension cord with a switch and use that, but I'm going with this construction for now. And if the other version with a step-up power converter works, you will see it right now. If it doesn't, there's no more content about the power supply. So, what do you think? Will there be more content about the power supply? Make your bets now. And so after disassembling the case completely, there is this metal frame which sits inside the plastic case. And yeah, I want to think about how to mount the Pi and all the stuff in here, because these ports have to go here. I have brackets for that. And the Pi has to be somewhere here. I think I will put it here somewhere. Just checking if the screws or the mounts will somehow work. If I do it like this could actually work. Let me check. So the idea is to put this in like this. Hey, this works. Awesome. Just have to make sure that it doesn't short out anywhere. So I think I will just use this double-sided tape here and put it just on here like this. Should do. So this should keep this from shorting out. Yeah, that's good. Okay, yeah, that's going nowhere. Didn't even need the sticky tape. A few of these brackets here, and 2 of these have these 9-pin cutouts, so I will just use these to put my joystick ports out. Number 2. Just like that, we have our first bracket, and we will put some electrical tape, the classic, over these open slots so that no dust comes in here. And since it is the push against here, it will also be no problem. You could of course 3D print custom brackets or just buy some, but I have these lying around here and I will use these. But you can do whatever you like. Okay, let's put this in here and screw it in. Joystick port number 1 connected. Nice. Let's do the same for the second one. And like that, we put it in next to the other. And that is the second joystick port. Oops. Connected. Nice. So that looks pretty clean, I think. Next up, I think I will remove the speaker somehow, but it's screwed in, and okay, this is also screwed in, so I have to remove this to get to this. So since we don't, oh no, this is not screwed. So we have to try to get it out somehow. I'll just bend it till it breaks, like this. Oh, nice. See, that wasn't too hard. And now I can get to the screw. We can already think about this right here. Yeah, that will be out here somewhere. So we can probably already put this in here. And also have the keyboard situation in order. Plug this in first. Yeah, of course, the other way around. That can go right here. That is a pretty clean build, I have to say. Looks good. This just goes in here, and here connects the keyboard, here connects the power, joystick, and we have all the external stuff taken care of. So after some debate with myself, I decided to put the speakers with some sticky tape on top so that they can actually sound relatively the same. And there's some holes for a speaker, but yeah, not sure how to do this. I have some more brackets, so maybe I will just use one of these brackets here so that the sound can come out. That could be an option. Or I just remove the tape from my joystick thing here and have here and here some kind of grill-like thing. That could also be an option. I think I will do that. That should be the best way to do this now. And I will have to route this outside the case. Cannot yet put all the cables in place. So I did continue the assembly, and I did put the control board for the LCD driver board up here. These are the LEDs from the front panel, which I routed through. Here is my USB cable to connect to the LED board, which I will not use. So this can pretty much go away, I think. lose this because the power situation is different. Still have this cable connected, which is if the other USB thingy works, which arrived, but I didn't test it yet, which is a step-up converter from 5 to 12 volts. No idea if it works, so you will see about that. I did put my thingy here, the extender of this cable which connects to the power supply. Did put this in here, and I just had to widen the hole a little, and that was where the metal bracket was for the second serial port, and this works. I have to put this on the side here where my finger is, and I just use double-sided tape to stick the adapter inside this plug, which then goes here, but that can only go in there when all the stuff on the front side is connected, so I will have to wait for that. I want to put in the power adapter, and that could go here, for example. Yeah, that's solid enough, let's say it. So on there we have all these cables, which is I will, I think, put this right here, and then I will have to extend this 12 volt cable to go through the hole to the front, because that powers the LCD. So I managed to route all the cables through here. I want to show you around. So I extended the cable for the LCD, which now goes over here, which is this red and black cable. I used some heat shrink tubing, but no soldering. I did put the volume control on the side here, which is not the best way to do it, but until I can do soldering, this is the way to go. The cables for the front slider, volume slider, are here. I connected the DIN connector for the keyboard, and yeah, the final step to do is to connect the power LED to the Pi. I need some resistor for that. I think a 330 ohms should do. And I will connect this to the Pi, and the red wire, or the plus, goes here on the first, on the right, like this, and then this should light up the power LED in the front. And yeah, so screen wise we are set. So the screen is in. If you push here and pull here, you can see there are the cables. It's not elegant, but it works, and I can have my screen like this. I have to put the handle back on here, which I will do next. And yeah, I'm pretty happy with how this turned out, because it actually does seem to fit all in here. So the handle is back on, which is great. Now comes the power supply, and the power supply is in. Cables are just hanging here because nobody really needs them. Now I will attach the drive cage. I hope that my own power supply is not in the way. I have nothing to put into the drive bay. I am waiting for Randy Rossi to actually enable the real 1541, because then I would go and would put a real 5041 in here to use with the BMC, because that would make for the ultimate modern SX64. So all that was left to do was to plug the power in, and yeah, I think we are good for a little test run. Let's do this. So here's the final product, so to say. Already plugged in the cable, and before I start it up, let's set it up. The keyboard, as before, attaches to the side. This you can of course pull the screen out, and then we just plug it in. And even the power LED is shining. I don't know why, because I actually didn't connect that. Strange. Okay. Yeah, so that is a pretty glossy display. Oh, and there's the LED dying and gone. Did I really connect that? Seems so. Well, it's dead now. That wasn't planned. I attached this LED because I already burnt out the power LED. I forgot to put the resistor there. I showed that in the video, and plugged it just in and left it there, and I was wondering why the LED was burning, and then it just went. And I don't have to, I don't want to solder right now, so I can't solder right now. So I had to use a different LED, and I just used some heat shrinking and heat shrink tubing and 330 ohm resistor and connected the LED, and it works. Nice. That thing doesn't. I have to use the dial on the side here, and it's cranked up to max volume right now. Yeah, what you see right here is the actual image of the machine, and if you press F12 you get into the menu and you have lots of options like switching the machine. If you go to switch here and you say VIC 20, for example, you can select which VIC 20 you would like to see, and let's say we want to see this one right here, and you say reboot and OK, and it takes 1, 2, 3, 4, 5, 6 seconds and you are in a VIC 20. So let's switch back to the C64, and I'm right now using the PAL HDMI VIC 768 by 545 at 50.125 megahertz. So a reboot, and here's a which is the sound. Yeah, and here you can see I have actually some settings active so that it looks a bit more on the side. I can see, so you can see it better. Some settings active that it gets a little bit more CRT looking. Yeah, and if you want to attach discs, you can do this here. Just select drive 8, attach disk, and you can select one of the discs here. Or you can go and go to cartridges and attach card, and then let's say Turrican, and I have drive sounds emulated. Yeah, that's the lovely Turrican. The name Turrican, or Turricano as it was originally, is from a phone book. So the developers didn't know what name to choose, and they just looked into a German phone book and found a family called Turricano, or Turricano, which is Italian, and so they selected Turrican as the name for the game. That's the legend. Yeah, and as you can see, you can run around, do stuff, shoot with just one hand. Let's try to beat Turrican one-handed. No, I can't do that. I'm really bad at this game. But there's absolutely no lag here. Let's quickly check the settings I have here, because you will need these if you want to use the joysticks the way I connected them. So keyboard, you don't have to do anything. That is just if you connect a C64 keyboard. Joy ports, I right now have my port 1 on GPIO bank 2 and my port 2 on GPIO bank 1. Doesn't really matter. You can just swap these ports, and this is what it does. It just swaps the ports. You can add more joysticks if you like, but that is not what we do here. And what you need to do is you need to check that your config is nav and joy, not keyboard and joy, not waveshare, not for, not custom, not disabled. It has to be nav and joy, because only then do these banks and these connections match what we have here. And if you did that, you just say save settings, and the settings are saved. And next time you boot, you get exactly these settings. I have drive sound emulation on, which is that you can hear 1541 in the background if you load from disk. Yeah, it's looking for files in the C64 directory, which is where the CRT and disk images and stuff like that are residing. I showed you that in the video when I set up the BMC64. So video, I have a shader on right now, and I have the Triniton mask type that gives these slight scan lines, which you can see if I hold the camera like that. Yeah, that is pretty much all there is to this. So now there's an SX64 in this nice case with a Commodore style keyboard, and it all just works. It's amazing. You can use 2 joysticks if you like. And yeah, what I would really like would be a real 1541, but well, it is what it is. So in the end, would I recommend doing that? Yes, I totally would, because it looks just awesome, and it is like a SX64 in a modern form factor with a great screen, good joystick, a nice keyboard. And yeah, would I do something different? Yes, I would spend probably less time doing this, because to be honest, this took weeks to film. And even though I'm wearing the same shirt in the first and the last scene, there's weeks between this and stuff I ordered and sent back, and that worked and didn't work. And yeah, I have a few things I would like to do if I am allowed to solder. First and obvious would be to actually do the volume control with this thing here and lose the one on the side. I would like to have a power switch, because right now I have to plug and unplug the machine. I would put the IR sensor from the controller board for the LCD probably in one of these LED spots over here. And then I could use the remote to control this, but there's not much to control because it already looks great, so nothing to see here. I would add an SD card extender so that I don't have to use pliers to unplug the SD card, because if you do configuration, there's no way you can use Wi-Fi or anything to connect to the machine, because there's no Linux. It's a bare metal machine, and so you have to remove the SD card, put it in the PC, make changes. And I had some sound issues, and I had to plug and unplug the SD card. On that note, if you do the audio setting that you use the analog plug, you have to put in the SD card in the machine once, then it copies stuff over, and it only works the second time around. So you have to unplug the machine after that, after boot, plug it in again, and then it works. And I would like to have a drive LED. Right now this HDD LED is for my power, LED, but I would really love to have a real HDD LED. And of course I would really love to have this portable and independent of a plug. That would be great. But unfortunately this thing to step up the voltage from 5 to 12 volts, it just didn't work good enough to power the LCD screen here. So there's no easy way to do a total portable machine, and that's a shame. At least no cheap one. So all the parts I used are in the description. All the websites I visited for stuff are in the description. This video took a while, so please like and subscribe and share if you can. And yeah, thanks for watching, and until next time. See ya. Bye-bye.
Thank you for watching Retro is the New Black. If you are new to the channel, please like and subscribe. If you like the video, please share. Every like, share, and comment helps a lot. Until next time, bye-bye.